So over here what we have is a simple prototype of an home automation system. So over here what is happening is we have an Arduino board over here. This Arduino board is connected to this LCD and this keypad, 4x4 keypad. What There is an input pin which is containing this LDR. The value of this LDR is stored in that input pin, and it is actuating this LED array. So the and also we have an LM35 temperature sensor. Over here we have it. Over here we have the LM35 temperature sensor. So what basically this Arduino board is doing is it is capturing the temperature and the light intensity, and it is storing it and doing some operations. So the operations that are done are, first of all, it is controlling this LED. So during real time what it is doing is in case if the light intensity is more than the specified light intensity, it is increasing the intensity of this LEDs, these LEDs. So over here in the LCD screen, you can see there are some values written over here. Yeah. So there is this 86. 86 is the light intensity captured, and it is taken average over 30 seconds. Okay, so that is the light intensity which is captured over 30 seconds. 24 is the temperature that is captured. So it is saying that 24 degrees Celsius is the current temperature. The light over here is the real time light that is that the LDR is capturing. So like it is fluctuating more because the refresh rate is 0.15 milliseconds. Sorry, 0.15 seconds. So this REQ90. So this is what is the desired intensity of light that is required, and this is the signal that is being sent to the LEDs. So what I can say is a 15 is the amount of PWM waveform that is being sent to the LED in order to control it. So the LED is okay. So the LED is connected to the LED is connected to a driver circuit, which is then driving the LED. As the current is high over here, so that way I have done it. And in order to specify this 90, what we are using is we are using the keypad. So as you can see, if I am, let's say, entering some value over here, let's say I'm entering 147. Okay, so as you can see, the LCD display has changed its required value, and now the light is trying to increase so that the desired value is between 147, is within the range of 147. Okay, so this is the function of Arduino. Now one more thing that Arduino is doing is it is transferring all this data to the Bolt Wi-Fi module. So this is the channel. It is using UART communication technique to transfer all the data. So the data that is being transferred is the mean light. So as I said earlier that there is this mean light, mean over 30 seconds period. So that light intensity is transferring 32, which is the temperature over 30 seconds, and 81, which is the this command, this PWM command over 30 seconds. So this thing we can say as U. So U is the input signal to the LEDs. So those things it is transferring through to the bolt module. So now what this bolt module is doing is, once it has received the information, it is then transferring it to my Python script. Okay, so there are multiple Python scripts running over here. So this is the one that is the through which it is transferring the data. So as you can see, how much it is, 78, 26, 140. So this is the previous value. Now later it will transfer the original value 152, 28 and 72, that it will transfer after 30 seconds. Okay, we'll see after 30 seconds. Okay, so 30 seconds have passed. So yeah, so you can see 74, 28, 152, which is same over here. Okay, so that thing is it is being passed. Okay, so once that these values are passed to the system, then what it is happening is the system is using it for multiple applications. So before telling that, what I need you to understand is, in case of electricity markets, there are real-time markets. So what happens in real-time market is, the value of electricity changes every 5 minutes. So over here if we see, what I have done is I have monitored the change in electricity market for a period of 1 day. So as you can see over here, so these are the changes in electricity rates in 1 day. So this is actually happening in California country, not in India. So in India it is not the case over here. Electricity rates are evenly distributed over 1 month or some amount, but in California electricity markets it is changing every 5 minutes. So what my goal will be, I need to, if I have heavy loads, what I need to do is, I need to I need to actuate those loads within this period. Okay, so this lower cost period now, I need to actuate those loads rather than actuating at these peak loads. So what will happen is my overall cost will reduce. So if let's say I have some application like electric vehicle charging, and or like electric water pump to store overhead water. In that case, what these loads are not compulsory loads. So like an indoor lighting system, these loads can be turned on and off as required, as not required by the user. So if I have an electric vehicle, I can charge it in the when the price is low, let's say at night, and I can use it in the morning. So that's the basic idea. So what I have done is, I have written a script which takes the real time value from the electricity market, and it stores in a variable, in a text file. So this one, so as you can see over here, this file, these are the real-time electricity market prices. So as you can see, it is 30.0927 dollars per megawatt hour is the electricity cost at present. So 0.48. So that's the current time. I'm recording it at night. So yeah. So next thing, what happens is, yeah, okay, so what is happening is, once the Bolt Wi-Fi module is receiving these values through UART communication, there is another script running in the background which is displaying these values to the user. So as you can see, These are the values that are being displayed. So I have been monitoring it for a long time, so it is not, it is reduced. But if I just zoom in over here, so over here what you can see is, yeah, so this one is the light which is changing the u value, sorry, not u value, it's the light value, light intensity that it has, the Arduino has sent. The green one is the cost of electricity, and the blue one is the temperature value. Okay, so these things I can display. So the script is displaying the those values. So what you can do is basically you can use Bolt's cloud module also to display these values, but the thing is I needed to display multiple values, so that's why I have used matplotlib of Python language. Okay, so that thing happened. Now the next thing is I have the data. I have all the data. I have the cost. I have the light intensity, and I have the temperature value. I have um, the U value, U, which is the sensor values. Okay, so now what I need to do is, in case I have to actuate the heavy loads, uh, which are the electric vehicle and the water pump. So what will happen is, they the intention over here is to have an have a electric sensor, so which can sense the battery status. But as I don't have that thing, what I have done is this, the first terminal of the Bolt Wi-Fi module, it is using it is sensing the positive and negative. So in case if I give a positive signal to this thing, then in case I give a positive signal to my sensor, what will happen is it will sense the that the electric vehicle and the water pump should can be charged now, as the battery sensor is showing that as the battery sensor is showing that it is positive, which means that the battery and the water tank is not filled up till now. So yeah, so in case if the sensor senses that a positive signal is applied, that means the voltage is, that means the battery status is not filled, so the battery can be filled. So what it does is, next it checks the current cost value. So what is the current cost value? Okay, so the current cost value, as you can see here, is 33.0927. So in case the cost value is less than the marginal cost, then what it will do is it will start charging. What I mean is, if the cost is in this region, that means it is less than 38, which is the average cost, or this region, then it will start charging the electric vehicle, or it will start or it will increase the it will start the pump water to the overhead tank. So in case I need to charge the battery, what I'll do is I'll put a plus VCC signal to this terminal. So if I just put it over here, which is the plus VCC sign, let's see what happens. So what it does is it compares the, as you can see over here, that the mobile is starting to charge and the motor is turned on. So what is it does is basically, I'll just shut it off. It's making noise. So what it does is, basically, if the cost is less than the specified cost, then it will, if the cost is less than the average cost over a day, then it will send the signal that okay, so the cost is low. What I can do is I can charge the battery now, so that would be more efficient. So yeah, so in that way the battery starts to charge and the water pump is turned on. Yeah. So that thing is happening. Yeah, the mobile is also charging. So yeah, you can see the mobile is also charging and the motor is still running only. Yeah. So that is the second script that I have written. Third script that I have written. First one was to collect the data from Bolt Arduino module. The second script was to display the values, and the third script is to control the electric vehicle and pump charging. Now the fourth script is, and one more script was for web scraping algorithm. Now the final script, yeah. So the controlling script, what it also does is, it also displays me the energy that is being consumed, or it calculates the energy that is being consumed and displays the graph of the total cost up till now. So this was the graph up, that is that how much cost of energy I have used. So over here you can see initially it was 0, it increased. So over here this period the motor, the heavy machines were not on. So this is 0. So over here I turned them on, and then I again turned it off. So okay, so now I think it is visible. So I turned it off, it was off, I turned it on, and I again turned it off. So now as you can see, now that I have turned it on again, the cost is shooting up. Over here you can see, so it is shooting. So up till now you can see it is like around $0.6. I have $0.6 of electricity I have used. So it is running for like 6 hours. So I think that much electricity I will consume if I use that. So that was the controlling script. Now finally the uh, last script, which is the anomaly detection. So what it does is, in case the value of in case the in case the it calculates the z score, and in case the energy is out of bounds, that means if there is a sudden rise in the energy, in that case it will send me a message. So send me a message and a mail. So let me just see if the mail has arrived. Uh, as now I just turned on the heavy vehicles, heavy machines. So yeah, these were the mails that came. Which one is sudden increase in energy consumption? Please monitor. So this went 10 minutes ago. So I think the latest one hasn't arrived yet, but yeah, it will come. Yeah, it will come. So yeah, so in case the it detects the anomaly. So it detects the anomaly, and in case the there is sudden rise in energy, then it will send me a message and a mail. And the second thing what the anomaly detection script does is, in case there is a, in case the cost of the energy is increased, like it has increased to a very high value, then also it will send me a message and a mail. Okay, so this was my project for Bolt IoT and ML application. Thank you.